Have you ever seen a soda bottle after you shake it up really, really hard? You know what happens when you twist that cap. Whoosh! A huge, foamy mess sprays everywhere. Well, in a way, our planet does something a lot like that. We call it a volcano. Think of it as the Earth having a big, loud, and sometimes messy tantrum. For thousands of years, people have watched these amazing events. We've seen mountains glow red in the night and heard the ground roar with a power that's hard to imagine. It's no wonder we are so curious about them. They are one of nature's most spectacular and powerful displays. A reminder that the ground beneath our feet is not as quiet as it seems. It's a living, breathing, changing system. This fascination isn't just about watching a good show. Understanding volcanoes is crucial. It helps us know why they happen and how to stay safe when they do. Why does a calm mountain suddenly decide to throw a fiery fit? What makes some eruptions quiet and gentle, while others are explosive and dangerous? By exploring the science behind these geological giants, we can turn our fear and wonder into knowledge. We can learn to respect their power while also appreciating the role they play in shaping our world. In this essay, we are going on a journey deep into the Earth. We are going to explore the 3 main reasons why volcanoes erupt. Let's get started. Let's start our journey by going down, way down, deep beneath the surface of the Earth. The ground you walk on, the crust, is just a thin skin on our planet. It's like the peel on an apple. Below that crust is a much thicker layer called the mantle. The mantle is mostly solid rock, but it is incredibly hot. Think about how hot an oven gets to bake a pizza. The Earth's mantle is many, many times hotter than that. This intense heat comes from our planet's formation and the slow decay of natural radioactive elements. This heat is the engine behind our fiery volcanoes. Now, this incredible heat is not the same everywhere. There are hot spots where temperatures soar even higher. There, solid mantle rock can melt. When rock melts, it becomes magma. Magma is less dense than the surrounding rock. Like a log rising to the surface of water, magma wants to rise toward the cooler crust. Melting into buoyant magma is the first ingredient of an eruption. This process creates huge underground chambers filled with magma. They're like giant holding tanks for future eruptions, slowly filling over thousands to millions of years. As they fill, pressure builds. Like a balloon, more fill means more pressure. This underground furnace is the fuel source, so the first major cause is simply heat, the Earth's internal engine creating pockets of melted rock, the lifeblood of a volcano. Now that we have our chamber full of hot, gooey magma, let's look closer at what is inside it. Magma is not just melted rock. It is also filled with dissolved gases: water vapor, carbon dioxide, sulfur dioxide. Deep underground, immense pressure keeps those gases dissolved, like an unshaken soda on a shelf. But that is all about to change. As magma rises, the pressure drops. There is less rock above it. Gases come out of solution and form bubbles. Like popping a can of soda, release the pressure and fizz. Bubbles rush to form. In magma, this is far more powerful. Approaching the surface, bubbles expand massively, taking up space and driving magma upward. Expanding bubbles are the primary force behind explosive eruptions. They make magma more buoyant, pushing it faster and faster. If the magma is thick, like peanut butter, bubbles get trapped, pressure soars, and the result can be a catastrophic explosion sending ash and gas miles high. So, our second major cause is gas pressure. Without trapped gases, eruptions are pretty tame. Lava oozes. With lots of gas and sticky magma, like Mount St. Helens, volcanoes explode. With runnier, less gassy magma, like Hawaii, lava flows gently. It all comes down to the big gas escape. We have our hot, buoyant magma and expanding gases pushing it upward. But how does it get through the Earth's solid crust? The crust is broken into gigantic tectonic plates, rocky rafts moving on the mantle. They creep about as fast as your fingernails grow, yet build mountains and open oceans over time. These moving edges become pathways for magma. Most volcanoes lie where plates meet. At divergent boundaries, plates pull apart, cracking the crust. Stretch it like taffy, pressure drops, mantle melts, magma rises. New cracks give magma a direct route to the surface. Along the mid-Atlantic ridge, volcanoes build new ocean crust as the North American and Eurasian plates drift apart. At convergent boundaries, one plate dives beneath another. Subduction. Water lowers melting points, creating buoyant magma. That magma feeds arcs of volcanoes, forming the Pacific's ring of fire. Plate tectonics provides the plumbing system for volcanoes. Pulling plates create rifts. Colliding plates create melt that rises through crust. Plate boundaries are the weak spots in Earth's armor. They're where inner heat and pressure break through. Without these cracks, magma would stay trapped. It's really that simple and that dramatic. When pressure becomes too great and magma bursts through the surface, it is no longer magma. Once in the open air, we call it lava. Lava is often over 1,000 degrees Celsius, 2,000 degrees Celsius. It flows downhill, consuming everything: trees, buildings, roads. Some lava creeps like hot tar. Other lava forms fiery rivers. Explosive eruptions shatter magma and rock into ash and gas that billow high into the atmosphere. Volcanic ash is sharp rock and glass. Dense clouds can turn day into night and collapse roofs. Ash can smother crops, contaminate water, and cause serious breathing problems. Ash plumes travel thousands of miles, disrupting air travel. Heat melts snow and ice, creating lahars, rivers of wet concrete that sweep away boulders, trees, even bridges. Eruptions can trigger earthquakes, and undersea blasts can generate tsunamis. Over time, cooled lava and ash build new land. The Hawaiian Islands rose from the sea, layer by layer. Volcanic materials weather into some of Earth's most fertile soils. That's why many people live near volcanoes. Rich land brings abundant crops. A volcano isn't random. It's a powerful logical process. Heat melts rock, gases expand, and cracks provide the escape. Heat, gas, cracks. 3 key ingredients for nature's grandest events. We can't stop eruptions, but by studying signals, building warnings, and planning evacuations, we can prepare. They connect us to the Earth's hidden power, a window into our planet's heart. Well, yeah, and that's pretty amazing.